Mike here. A little hiatus from my refrigeration work, but here in the last few days I've made a few new parts and thought I'd share them before I make a few more. So the first one, something I've made quite commonly now, they've gotten to be pretty routine, is this thermocouple refrigeration sensor that'll get mounted directly into a refrigerant stream. Actually, it'll go right into a column of refrigerant, almost exactly identical to this column here that's oftentimes filled full of liquid. This stub will get brazed into a hole, and then the thermocouple sensor will get inserted, and then the flare nut tightened down. Pretty simple. Haven't pressure tested it yet because I'm out of nitrogen. But second thing was this racetrack coil. This is going to get hopefully used as a source of superheat for a TXV to control the liquid level inside of a column of refrigerant. Don't know if it's going to work yet. Always kind of wanted to try to make one before, and now I don't want to make one anymore because it was a pain in the ass to do. They use a tubing bender, and with these 180-degree loops, it was really difficult to manipulate the tubing bender in there. It's not quite perfect, but it's good enough for my purposes. So I'll explain what that is a little more here in the future. This is a liquid receiver, at least it's intended to be. Quite simply, we have a 1/4 inch line into the top, 1/4 inch line out of the bottom. More or less it expands to 1 inch. You can see how I kind of pillow pocketed this this 1 inch pipe here, just smashed it at the top and brazed it. Same at the bottom. This allows me to get a liquid level up to this sight glass here. It's a 1 inch glass sight plug. Seeing back in there, I don't know how difficult it's going to be. Once there's liquid in there, of course it'll come all the way out to the glass itself. I found that if I shine some light on it, hold a flashlight right up against it, you know, on the corner of it, I can see pretty well in there. So this was just kind of a test piece. I didn't really need a liquid receiver. I mean, I might find it comes in handy, but it was an opportunity to test, you know, my brazing skills, ability to saddle a piece of 1 inch, a 1 inch adapter. So you got 1 inch female pipe thread to 1 inch sweat, and to saddle that, pretty much just drew lines on there, and I cut it at 45-degree angle, both ends. So, you know, total of about a 90 there. You know, so a lot of it was actually kind of done. You know, I didn't have a chop saw or anything like that, so I drew it on there with marked it with a Sharpie, and then cut it off with the cutting wheel and the Dremel tool. But you see, you end up with kind of a nice round shape. It wasn't quite that round. After I was done cutting, I put a piece of 1 inch pipe down in the saddle, and then just kind of ground it with the Dremel tool until I got it fairly close. With this one, what I did was I sat, see it, kind of sits on there pretty nicely. Not much gap there. Should be easy to braze. Took a Sharpie and just drew on the inside there, and then cut it out with the Dremel tool. Then cleaned up the hole. Yeah, it was actually pretty easy to braze. But the next column that I'm going to make, that column is actually going to have 3 sight glasses, so I have to cut this one as well. It's going to have one right below the other, and that will be where the more or less the liquid level is maintained. And then I'll have a straight view through sight plug. 2 sight plugs, you'll be able to actually see through it. Maybe shine a flashlight through one end, get a really nice, easy to view, easy view of what's happening in there. And what's intended to be happening in there is this column is going to be vertical, just like the other one here, and be able to look straight through the column. And the reason I want to be able to look straight through it is because there's going to be 2 lines that are coming up through the bottom and terminating right around the height of that view plug. Those 2 lines are going to be depositing liquid vapor combination into the column, and one of those saturated liquid vapor lines is going to be coming from the needle valve. This is a gate valve here, but it's going to have a needle valve, a little tighter control. which is actually going to be fed from this tank. This other tank I'm talking about is going to be mounted up here. So that'll be feeding liquid from the medium pressure column into the low pressure separator column. The other line is going to be the discharge from the evaporator. So this tank is going to be a common volume to both the top and the bottom here. The bottom is going to be fed by some liquid coming off of the bottom of the tank, and the top, after some ebullition occurs and some violent boiling, liquid vapor combination comes spilling out over the top, it's going to come spilling out in that line that's going to be visible through that sight plug. And so I really wanted it there to get a really good idea of how changes in system pressures and system the operation of the fan, obstructing airflow, affects the amount of liquid coming up and bubbling through. So I wanted a good observational tool to be able to see what's going on in there. I'm also going to be able to see what the quality of the refrigerant coming from the needle valve is too. So that could be kind of interesting, just to kind of wrap my head around how much liquid is flowing through. I don't know flow rates or anything like that yet. This is just an empirical method to better understand what's happening in there. So there's going to be a lot of stuff going on. There's going to be a thermocouple installed, the 3 sight plugs. It's actually going to be 3 lines coming in the bottom. There's going to be one from the needle valve from the medium pressure column. There's going to be one coming from the top of the ebulator. And there's also going to be one feeding liquid from the bottom of this column I'm describing to the bottom of the evaporator coil. So liquid will be coming off from the bottom, and liquid vapor will be spilling over from the top. And then, of course, we have to have a suction, which is going to be done by the ejector, the original ejector. I'm going to have to reposition some of this stuff and run some new lines. So that's going to be interesting to figure out how all that's going to play out. So that'll just be one line coming off the top, pulling back to the ejector, pulling saturated, mostly saturated vapor back. There's also going to be a pressure gauge installed. So there's a lot of stuff going on in that one little column. Let's see. I think that's pretty well it. Other than the one last thing that's going to really make things interesting is the racetrack coil. So those lines aren't going to necessarily be as long. I just got a little extra to play with. So that's going to be installed in the side of the column. It's going to be up here somewhere, maybe off at an angle depending on how it works out. And the bottom line on that racetrack coil is going to probably be inserted right around where the height of the liquid, and we got some cats fighting over there, right around the height where the liquid's going to be maintained in that column. So this lower sight plug is going to give me an idea where the liquid is at. The notion with this, the idea with this thing, boy it is windy, is I want to have a superheat coil. Okay, so the liquid vapor that's inside this column that I'm describing, not the receiver itself, it's just for example, is mostly in a saturated state. So if I want to actually use, say, a TXV, I need to have some superheat. Now I could trick it and use electronics or something like that, but then I still need a method to actually measure how much liquid, the height of the liquid in the column. So by using this racetrack coil, what I hope is that if the liquid level gets high enough, there's going to be plenty of liquid inside this coil, being able to pick up heat because it's got plenty of surface area. And by placing a TXV sensing bulb somewhere on one of these rungs, I gave myself a little bit of option here by having a few runs. It will cool down the sensing bulb and therefore closing the TXV slightly, so the liquid level stops to rise. If it closes too much and starts to actually drop back below this intended liquid level and starts to dry out the coil will naturally start to warm up. When it does, it starts to open up the TXV and emit more liquid. So hopefully I can get it tuned to the point where I can essentially have a simple float control. It might not work at all, I don't know. Initially I'm going to be controlling, metering this column with a 3/8 inch needle valve. Probably just going to take some direct temperature measurements somewhere on one of these rungs or several of the rungs at once, and observe how liquid level changes those temperatures. Time will tell. We'll see what happens. You know, I need to figure this out. Figure out how I'm going to control liquid in this, because as it is right now, it's in largely a manually operated device. And if I hope to build a heat pump for this winter, I'm going to have some automatic controls, and I'm trying to keep them relatively simple, all mechanical. As it stands right now, the only thing electrical in this device is the compressor itself and the fan motors. I don't have a problem with electronics. I'm just not particularly familiar with electronics, data collection, fidgets, Arduinos. I mean, it's not that I'm unable to acquire the knowledge. It's just that I don't really have that much interest in it. This is what I enjoy. I enjoy things that's simple and mechanical. Might not look that simple. It's going to get a hell of a lot more complicated, but I still think it's a fairly simple device that's you know, pretty much everything that's going on is right in front of you. It's not there's no magic involved. So anywho, I better get to work. Thanks for watching.